In our lesson today, we're going to look at another application of multiplication, which is involving exponents. And then later on in the lesson, we're also going to have a review of all of the operations that we have worked on so far this year. So let's take a look at our exponents. Exponents, if you remember, allow us to repeatedly multiply by the same number. For example, okay, this is read as 5 to the third power, all right? And what this means to do is that I'm going to take the number 5 and I'm going to multiply it by itself 3 times. 5 to the third means to do 5 times 5 times 5. Okay? The 5 has a name, okay, and this is called the base. And the base is the number or expression that is used as a factor in repeated multiplication. Okay, so this was the value that was repeatedly getting multiplied. The 3 is called the exponent. Okay, and the exponent tells you how many times to use the base as a factor, how many times you're going to multiply it by itself. So this is the exponent, all right, the exponential notation, 5 to the third power, and this is the expanded form when you write out what it means to do, 5 times 5 times 5. Now we're going to evaluate and see how much that is. 5 times 5 is 25, and 25 times 5 is 125. So 5 to the third power is equal to 125. This was a positive number. If your base is a negative number, then you need to think about whether the answer will be a positive number or a negative number. Example number 1, we're going to write each exponent as a multiplication problem, and then we're going to evaluate it. So notice my base here is -2, and it's going to be -2 in all of these examples. And again, the exponent tells you how many times you're going to multiply -2 by itself. So in this first example, it's very straightforward. I just need one copy of -2. And there it is, okay? Any number that's raised to the first power is going to give you that number back. -2 to the first is the same as -2. -2 to the second power, this also might be called -2 squared. That means I'm going to do -2 times -2. And when I do this multiplication problem, remember that a negative times a negative is a positive, and 2 times 2 is 4, so -2 times -2 is +4. -2 to the third power. When you raise something to the third power, they might also call it cubed. -2 cubed means to do -2 times -2 times -2. Okay, and now if we do the multiplication, -2 times -2 we just said was 4. So we have to do 4 times -2. A positive times a negative is a negative, and 4 times 2 is 8. With letter D, -2 to the fourth power, that means to do -2 times -2 times -2 times -2. And now again, we'll go from left to right. -2 times -2 was 4. Bring down the rest of the problem. 4 times -2 we just said was -8. So we have -8 times -2. Again, a negative times a negative is a positive, and 8 times 2 will give us 16. Finally, in letter E, -2 to the fifth power. We're going to have 5 copies of -2 that we're going to multiply by itself. There's what -2 to the fifth power looks like in expanded form. And so now when we evaluate, again, -2 times -2 is 4. Bring down the rest of the problem. 4 times -2 was -8. Bring down the rest of the problem. -8 times -2 we just said was 16. And so now we have 16 times -2. A positive times a negative is a negative. And 16 times 2 is 32. So hopefully you're seeing a pattern, all right? In example number 2, do you see the pattern? We're going to fill in the blanks below. If a negative number is raised to an even power, okay, well that would be this example right here in letter B and this example right here in letter D. Every time that we raised the negative number to an even power, our answer ended up being a positive. So you will get a positive result if you raise a negative number to an even power. But if you raised your negative number to an odd power, like in example A, example C, and example E, notice this time that that's going to give you a negative result. A negative number raised to an odd power will give you a negative result.
In each of our previous examples, every time that we had a negative number being raised to an exponent, we needed to use parentheses in that example. Forgetting the parentheses can lead to an incorrect answer. All right, for example, if you have -5 not in parentheses squared and -5 in parentheses squared, these will actually not give you the same result. All right, let's take a look at what each one of these means to show that they are not the same. All right, if you have -5 being raised to the second power and that -5 is not in parentheses, it's important to remember that this negative symbol right here is really the number -1. All right, and that -1 is multiplying 5 to the second power. So this means to do -1 times 5 squared. Right? And then what we need to do first before we multiply by -1, we have to actually evaluate how much 5 to the second power is. All right? Well, 5 to the second power is equal to 25. And so now this means to do -1 times 25. And -1 times 25 is -25. Compare that now to when we have our negative number written inside of parentheses. Okay, so this is similar to the previous examples. When the number is inside of the parentheses, this means to take the number and multiply it by itself, in this case, 2 times since we're squaring it. So this does mean -5 times -5. And if you were to multiply -5 by -5, you would get a positive 25. All right, negative times negative is positive. So notice, without the parentheses, we end up with a negative result. But with the parentheses here, we get a positive result. The result is not the same. The answers aren't the same. So again, forgetting the parentheses could lead to an incorrect answer. If your base is negative, make sure that you put it inside of parentheses before you square it.
The next part of our lesson is going to focus on the order of operations. In mathematics, there's a proper order that needs to be followed when there's multiple operations within an expression. If you don't follow the order of operations, then you won't be able to come up with the correct answer when you try to evaluate your expression. In example number 1, Bobby said that the answer to the expression below is -3. Is Bobby correct or incorrect? Okay, the expression says 6 divided by 3 minus 4 times 2 plus 1. And then he thinks the answer is -3. We have to follow the order of operations in order to see if he's correct. Okay, so let's review the order of operations. The very first thing that you're going to have to do whenever you're looking at an expression is evaluate any expressions within grouping symbols. Grouping symbols. Okay, any operations within grouping symbols need to be evaluated first. And the most famous grouping symbols would be parentheses, which we know looks like this. Okay, but other grouping symbols could be brackets, which are like square parentheses if you draw them like this. Okay, or braces, which are those kind of squiggly looking things like this that are a lot of fun to draw. Those are called braces. And another form of grouping symbols that we've actually talked about before this year would be absolute value bars. Like that, okay? Any operations that are inside of these grouping symbols need to be evaluated first. After you evaluate expressions within grouping symbols, then you can evaluate any exponents that you see in the expression. Following your exponents, next is going to be multiplication or division working from left to right. Working from left to right. Okay, multiplication and division are on the same level, so whichever one happens first in the expression, that's the one that you're going to do first. And then the last layer is addition and subtraction, again working from left to right. If the subtraction shows up first in the expression, you'll do the subtraction first, and if the addition shows up first, then you'll do the addition first. So, keeping this in mind, we're going to see now if Bobby was correct when he said that the answer was -3. So here's the expression that Bobby had above, and we're going to follow the order of operations and see if we get the same answer of -3. So evaluate any expressions within grouping symbols first. Well, in this problem, I don't see any grouping symbols at all, so I'm going to move on to the next level, which would be exponents. And again, looking at this, I don't see any exponents, so we're moving down to the third layer, multiplication and division, working from left to right. So going from left to right, I see a division problem first, so that's going to be the first thing that we need to evaluate. 6 divided by 3 is 2. Now bring the rest of the problem down. -4 times 2 plus 1. Still on level 3, again, any other multiplications or divisions that we see have to be done first. I see subtraction. There's another multiplication right there. So I'm going to bring down my 2 minus, and now I'm going to do 4 times 2, which is 8, plus 1. Okay, and that takes care of all the multiplications and divisions. We're only left with subtraction and addition, so we're on the last part of our order of operations now. And again, we have to go from left to right. So 2 minus 8 is the first part of this problem. 2 minus 8, remember, is the same as 2 plus -8, and 2 plus -8 is equal to -6. So this gives us -6 plus 1. And so the last thing that we have to do now, -6 plus 1, this is going to give us an answer of -5. Bobby said that the answer was -3, so we can safely say now that Bobby was incorrect. Bobby was incorrect. Okay, Bobby's mistake was that he just worked straight from left to right, ignoring the order of operations. Okay, so make sure that you follow this proper order so that you can come up with the correct answer anytime you evaluate an expression. In example 2, we're going to evaluate each expression, and it's important to show all steps in your calculation. So looking at letter A, okay, here's our expression, and I'm looking for grouping symbols first, and I actually see an operation in the grouping symbols. Addition is inside of the parentheses. So this is the first thing that I'm going to do in the problem, -2 plus 4. Okay, so I'm going to bring everything else down, -8 rather, plus -3, and then when I do -2 plus 4, that gives me an answer of 2. And then notice there's an exponent, so I have to put that above there as well. So our expression now says -8 plus -3 times 2 to the second power. Okay, now this parentheses here, these are grouping symbols, but there's no operation in the grouping symbols. So we're going to move on to the next step, which is exponents. And this right here says to do 2 to the second power. So again, I'm going to bring everything else down, -8 plus -3 times, if you do 2 to the second power, 2 times 2, that gives you 4. Okay, looking at this now, I see addition and I see multiplication. I'm going to do the multiplication, so -8 plus -3 times 4. A negative times a positive is a negative, so that's going to give us -12. And the last thing we're going to do is -8 plus -12, which is -20. In example B, what we're going to do first, again, I'm looking for operations and grouping symbols. These parentheses, all right, do not have an operation, so I'm ignoring that. But this grouping symbol, the absolute value bars, does have an operation, so we're going to do that first. So we're going to have 3 squared plus -2 to the third power plus the absolute value of -6 plus 2. -6 plus 2 is -4. Okay? Now we're actually going to take that absolute value. So again, we're going to have 3 squared plus -2 to the third plus the absolute value of -4 is 4. Next, we're going to do our exponents. 3 squared, 3 times 3 is 9, plus -2 to the third power. If you remember from earlier in the lesson, -2 times -2 times -2, that was -8, plus 4. And now just its addition, go from left to right. 9 plus -8 is 1. And finally, 1 plus 4 is 5. Another form of grouping symbols would be the fraction bar. If you have an expression in the numerator and or the denominator of a fraction, you need to evaluate those first before you can do the division represented by the fraction bar. Okay, so I have expressions in both the numerator and the denominator. So what I'm going to do, I'm going to start with the numerator. All right, I have division but parentheses here, so that's going to be 35 rather, divided by 5. In the denominator, I'm going to multiply first, so this is going to be 20 minus 14 plus 1. All right, in the numerator, 35 divided by 5 is 7. 20 minus 14 is 6. And then 6 plus 1 is 7. So this is 7 divided by 7, which is going to give us a final answer of 1.